Let's go to Leica 968 binary tree cameras. We are giving a root of a binary tree. We install camera on the tree nodes where each camera at a node can monitor its parents, itself, and its immediate children. Return the minimal number of cameras needed to monitor all nodes of the tree. So example one, right? We just need to place one camera here, and it can monitor its parents. It's in left and right child in itself. So one is enough. And example two, we need the minimal number of cameras is two. So so for this question, what we're thinking about is that we can greedily um, do the post-trade traversal to place the cameras. So how can we greedily do post-trade traversal? Is that for every we call DFS for us a node, right? It will return three states. So private int DFS. So we need to pass in the node, right? So it will return three states. So what is the three state? State zero will mean this tree, the tree node, the tree, right? The subtree of node can not be covered. And one means will represent we are going to place a camera at a node. And also there is another state which we are going to represent the tree can be covered, and there is no camera at node, right? So for the case two, that means either it's if it's not null, right? So that means if this node is not null, either its left child has a camera. Left child, if DFS that is one, right? Or right child, its DFS is one. So the for this kind of DFS, right? So what we need is we greedily from the leaf nodes to roots. So the things that if cannot covered, right? We do not place we are not necessary to place a node right now because it is possible it will be covered by its parents. So we just return zero, right? Until we traverse back to the root, right? But when we traverse to the root, if root returns zero, right? If it returns one, right? One or two, right? So if we return one, we'll add one, every node will add one camera. If two, right, we just also traverse. Um, and only for the one case, we are going to add a result, right? But when we traverse to the root, if it returns zero, if it is return one or two for the root, then we can add the total result, right? If it is, we can have a global variable called counts. If we traverse to root, the root is not covered. We should add one more camera at the root because there is no parents anymore, right? So it is we because the root is not covered, the tree is not covered. So we should add one more camera here, right? So we need to pass in the counts result with new int one, right? So what we do is the DFS root result. So we need about result. So for this kind of DFS, what is the exit condition? Is that if this node equals 2, right? So this is not um, this will be the same as a two case, right? So because we don't need to place any camera for this node. And also we'll say this null node is being covered. So we just return 2. So then what we do is that have int left result equals DFS node dot left result and int right result equals DFS node dot right result. So what we need is that if left result equals to 0 or right result equals to 0, if any left child or right child, anyone is not being covered, right? So we have to put a camera at current node. So we'll have result 0, the increase by 1, and we return 1, right? Because we place a camera here. And we'll say if left result equals 2 and right result equals 2, right? Then we return 0, means this node cannot be covered. And we're not necessary to place a camera right now because it is possible it's being covered by its parents. And the other case is return 2, right? So that means um, this is the same as left result equals 1 or right result equals to 1. Mm, if it's not null, right? So in this case, we DFS from its leaves to its to the root, and we also need to have a root state, right? So that means that if greedily we do post traversal, if in the end, if it is return 1 or 2, right, we just return result 0. But if it is return 0, right, if RS is 0, we don't have any parents node to cover root. So we should add one more camera. So what we return is return equals 0. This will be result 0 plus 1. Otherwise, it will be result 0. Right? So doing like this, because we are doing the post tree traversal, every node will be traversed once, so it will be O(n) time complexity. In the space, the DFS depth will be OH, right? So the space will be OH space complexity. And we can also write Python code for this. So we can have a global variable called self result equals 0, right? So we define DFS. So node, right? So this will be this. And it is returning int. So we'll say if not a node, right? If this is none, we return true, because this will be the same case as it's not covered, it's covered and no camera at the current one, right? So we can treat as a special case as no camera because this is none, right? With and it's no camera needed and it's covered. So have left result equals DFS node dot left. Right result equals DFS node dot right. So we'll say if left result equals 0 and right result equals to 0. That means if left child is not covered or right child is not covered, we have to place a camera at current node. So we'll have self dot result to the plus equal to 1, right? And because we place camera here, right, we should return 2. Means return 1, right? Means we place a camera here. And then the other case is if left result equals 2 and right result equals 2, right? Means left child are covered and the right child are covered, but no cameras placed at left or right child. Then we return 0. We don't need to place the camera right now. And the other case is return 2, right? So in the end, what we do is that return self of the result plus 1 if DFS root equals 0, right? If DFS, because for this one, there is no parents to be used anymore. Otherwise, else, so if DFS root equals 1 or 2, that's a self-delivery result.